Stats kids, this is Dr. Callahan with Week 12 Monday. How are you guys doing? All right, let's go ahead and take a look at what we're doing today. So we are starting a brand new unit. We're done with financial math, and now we're moving on to Euler circuits and path. So take a look at our guided notes today. So if you're at home, you should have the guided notes. You can actually just copy it down on a separate piece of paper, but if you're with me in class, this is what you should have. This is your first page, and here is your second page. First, if you would like, we can go ahead and get started. It says, after watching the video, provide a summary of how to identify the Euler circuit and path. Here is the tiny URL. You're welcome to go ahead and type it in and start with that first if you're doing this at home. And then with that said, let's go ahead and get started with the notes itself. Okay, so first things first. So you should have a network is a figure made up of points, vertices connected by non-intersecting edges. A vertex is the intersection of two edges. And the vertex is like that little piece right there. A vertex is odd if it is connected to an odd number of edges. So if you take a look over here, well, actually, before I do that, and vertex is even if it's connected to an even number of edges. So looking at this here, you have 1, 2, 3, 4, 5, 6 different vertex. And the edges connecting to this, you have 6. So here you have an odd vertex because it is connected to the odd number of edges. 1, 2, 3. 1, 2, 3. This right here is an even vertex because it's connected to 2 different edges, which is an even number of edges. This right here is considered to be an edge. And Euler path is a continuous path that passes through every edge once and only once. So for example, if I were to go 1, 2, 3, 4, 5, 6, and I stop, notice how I did not touch any other edge. However, if I do go through here one more time and go through here, then obviously it is going through this edge twice. A Euler circuit is an Euler path begins and ends at the same vertex. So here's Euler's first theorem. If a graph has any vertices of an odd degree, then it cannot have an Euler circuit. If a graph is connected and every vertex has an even degree, then it is at least one Euler circuit. All right, so is this an Euler circuit or path? Let's take a look at this. So looking at these numbers here, it's basically asking you from this vertex, how many edges is it connected to? 1, 2, 3. Therefore, there's 3. From this one here, how many is it connected to? 1, 2, 3. Therefore, it's 3. From this vertex, 1, 2, 3, 4. Therefore, it's 4. Here, 1, 2, 3, 4. Therefore, it's 4. And from here at this vertex, it's only connected twice. So let's take a look at this one here. How many vertices are there? Vertices mean the little dots. So looking at this, 1, 2, 3, 4, 5, 6. Oh, and I missed one. This vertex here, it's 1, 2, 3, 4. All right, so then how many vertices are there? There are 6. 1, 2, 3, 4, 5, 6. How many edges are there? If you look at it, edges are these numbers, or are these, oops. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many vertices have a degree of 2? 2 just means there are 2 edges to the vertex. So I would say that there is 1, 2, 3. How many vertices have a degree of 4? So it has 4 edges. 1, 2, 3. Draw a Euler circuit starting at the vertex with a white dot. Remember, a circuit travels along every edge exactly once and may pass through the vertex multiple times before ending at the starting vertex. So for example, if this is mine, it's in shape of a star and it starts from here, keeps going along the path, and it also ends at the starting point. Can you find a Euler path or circuit for the following network? So are you able to do this just once? This one here is a Euler circuit. And remember, a Euler circuit is when a Euler path begins and ends at the same vertex. Remember, a Euler path is a continuous path that passes through every edge only once. So if you look at this right here, you start right there. 1, 2, 3, 4, 5. You start and end at the same part. This one is a Euler path because if I start here, 1, 2, 3, 4, 5. Actually, let's try this one more time. If we start here, 1, 2, 3, 4, 5, 6, 7. I can get through here and it doesn't touch any other vertices. So in conclusion, based on the observation on the table, a graph with all vertices even contains a Euler circuit. A graph with 2 odd vertices and the rest even vertices contains a Euler path. A graph with 2 or more vertices does not contain a Euler path or circuit. All right, so next one I want you guys to do is pause the video and answer the following questions. For this, use the table at the bottom of the page to determine if the following graph contains a Euler path, a Euler circuit, or neither. So pause the video and try your best here. This one is a Euler circuit, Euler circuit, Euler path. And the reason why this is a path is because it goes 1, 2, 3, 4 across 1, 2, 3, 4. This one here is also a path because you start at this vertex 1, 2, 3, 4, 5, 6, and you go through. This is going to be neither, and this is neither. So looking at the chart, let's go ahead and fill in the blank. Here are the number of odd vertices connected to the odd number of edges. So graph 1 is 0. Even vertices, and there are 10 because 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, those are both even. And then take a look if it's a path or a circuit. All right, so let's take a look at this one. Name a Euler circuit. One possible solution is if I start with a D right here. Let's go ahead and start here. From D, I go to E, F, A, D, C, A, B, D. Go ahead and give me another one. This is another one that you can have. Given that this is a Euler path or a circle or neither, how can you tell? Explain your answer. So if you look at this right here, this one has 1, 2, 3, 4, 3, 4, 3, 2, 4. So there are 2 odd and 1, 2, 3, 4, 4 even. All right, so after this, I would like you guys to go ahead and do a quizzes to kind of work on this a little bit further. So I'm going to go ahead and have you guys start this. It is going to be due today. So go to joinmyquiz.com and then type in 364-83474. There are 15 questions and you guys are welcome to do this. So once again, joinmyquiz.com, 364-83474 is what you should be working on. All right, next what we're gonna do is we're gonna take a look at this video. You can go ahead and type this video in. And when you're done watching the video, I want you to go ahead and create your own Euler path and circuit and make sure you guys include the answers. All right, you guys, as always, stay safe and healthy, and I'll see you guys next time. Take care.